Assalamu alaikum students. Hope all of you are fine by the grace of Almighty Allah. In our previous class, I have discussed about the chemical reactions, irreversible reactions and reversible reactions, which is the classification of chemical reaction according to direction of chemical reaction. And today at first I will discuss about the classification of chemical reaction according to the heat change. Okay, according to the heat change, reactions can be classified into two types. One is exothermic reaction and another is exothermic reaction. Any chemical reaction is accompanied by or with heat change. Okay, by or with heat change. And at first, and these may occur in two ways. At first, exothermic reaction. Okay, the exothermic reaction is one which release energy or evolve energy as a heat form. Okay, that means the exothermic reaction is one which release heat energy and causing the temperature rise in the surroundings. Okay, release heat energy with causing temperature rise in the surroundings. The chemical reaction, that means here with products heat energy is also produced. Okay, and if we can give example in Haber process, the industrial production of ammonia, nitrogen 1:3 ratio. Okay, 1 mole nitrogen reacts with 3 mole hydrogen and produce 2 mole ammonia. Okay, ammonia, 2 mole ammonia gas. This is the exothermic reaction. Okay, that means with this product here 92 kilojoule per mole. Okay, per mole, kilojoule, K capital small letter, J capital letter. Okay, kilojoule, 92 kilojoule heat energy is produced with 2 mole ammonia. Okay, and this reaction is a good example of exothermic reaction. And we can also express this equation like that. 2 ammonia and del H is equal to minus 92 kilojoule per mole. Okay, del H means the enthalpy change or heat change. Okay, the value of heat change, del H means H represent heat and del difference. Okay, change. That means for this reaction the heat change value is minus 92 kilojoule per mole, and we can express this equation like that and also like that, and you have to write this along with this. Okay, but without any sign. Okay, plus or minus, and this value negative, the del H value for exothermic reaction is negative, and this negative value means that for exothermic reaction, here for exothermic reaction always the heat is transferred, from these chemicals to the surroundings. That means if we consider our reaction vessel, okay, our reaction vessel, nitrogen, reaction vessel as a system, okay, as a system, then from this system energy is released or evolved to the surroundings. That means environment. Okay, and that's why heat change is negative for exothermic reaction. Okay, and now the endothermic reaction. What will be the definition of endothermic reaction? The endothermic reaction is one which absorbs energy or heat, causing temperature drop in the surrounding. That means for endothermic reaction, in case of endothermic reaction, heat energy is absorbed by chemicals, absorbed by system, and that's why the temperature of the surrounding will be decreased. Okay, and the example of this reaction is any decomposition reaction and is endothermic reaction generally. Okay, if we take calcium carbonate, produce calcium oxide and carbon dioxide. Okay, carbon dioxide. Okay, and this reaction is the endothermic reaction, and for this reaction the heat is absorbed, so we have to write plus heat. Okay, that means we have to mention the heat energy, the amount of heat energy with the reactants. Okay, and these reactants absorb the heat from the surrounding and produce calcium oxide and carbon dioxide, that means product. And for that, the del H value, if we express using this del H, then this value will be plus. Okay, this value will be plus. Okay, and this plus means here for endothermic reaction, the heat energy is transferred from surrounding to the system. Okay, from surrounding to the chemicals. That's why the value is plus. The value of del H will be plus. Okay, and I think it is clear. And to detect a reaction as the exothermic or endothermic reaction is very easy. Okay, if we put a thermometer, into our reaction vessel, and then if we see the temperature is increased, then we can say this reaction is exothermic reaction. And if we see the temperature is decreased during the reaction, then we can say easily this reaction is endothermic reaction. Now I will discuss about the classification of chemical reaction according to electron transfer. Okay, and according to electron transfer, our chemical reactions mainly classified into two types. One is redox reaction and another is non-redox reaction. Okay, today I will discuss about redox reaction. Redox reaction means oxidation reduction reaction. Okay, we can abbreviate oxidation and reduction and just call them redox in short. Okay, red for reduction and ox for oxidation. Now we have to learn what is oxidation reduction or redox reaction. Simply, the simple definition of redox reaction is movement of electron moves between atoms. Okay, electron moves between atoms. Look at this diagram. Atom A, we have two atom B. Okay, atom A and B, we have two atoms, and there is an electron. There is an electron moving out of from atom A into atom B. Okay, this is the electron. So this is definitely an oxidation reduction reaction. That means a redox reaction. Okay, because here there is an electron moving between these two atoms. So, and now we can describe these using oxidation and reduction term. Okay, these two, using these two terms. And the oxidation is, what is oxidation? We have to know. Oxidation is loss of electrons. Okay, and the opposite, reduction is gain of electrons. Okay, oxidation means loss of electrons and the reduction is the gain of electrons. And again, look at this diagram. Atom A, we can easily observe that atom A is giving up one of its electron, okay, one of its electron, and that means it's losing an electron. That's why in atom A, oxidation takes place. Oxidation takes place in atom A. And on the other hand, atom B is B is receiving electrons, okay, receiving electrons, and that means it gaining electron. That means in atom B, reduction takes place. Reduction takes place. And we can now explain this situation like that. Since atom A is undergoing oxidation, that means atom A is being oxidized. Okay? Atom A is being oxidized. And since on the other hand, atom B is undergoing reduction, that's why we can say atom B is being reduced. Okay. Atom A oxidized by oxidation and atom B reduced by gaining an electron in reduction process. Okay. And this is the oxidation reduction concept. But the word reduction can make you confused. Because when we reduce something, that means we get less of it. Okay, but in that case, here the gain of electron is called reduction. Okay, and we can think this concept like that. Gain of electron is known as reduction, is called reduction, and electron has negative charge, one negative charge. Okay, and when we add electron to something, and then its charge goes down. Okay, suppose any atom with +3 plus charge and these with 2 charge, 1 charge, as we add electron. Okay, as we add electron to any atom, then the charge on it reduce. Okay, one negative charge add with 3 plus 1 charge, then it will be reduced to 2 plus. And if we add another electron, then it will be 1. And then 0, -1, -2, -3. That means as we add electron, and the charge, number of charge on any atom will be reduced. Okay, and I think still this oxidation reduction and can be confusing to remember, and so for that I will give you a trick. Okay, and this is two term, oil and rig. Oil and rig. Oil means oxidation. Oxidation is loss of electron. Okay, our rig means reduction is gain of rig, Z for gain of electrons. Okay, oil means oxidation is loss of electron, rig means reduction is gain of electron. I think these two words will be helpful to remember what is oxidation and what is reduction. Now let's take a chemical reaction in which oxidation and reduction takes place. Okay, and sodium and chlorine coming together to make sodium chloride. Sodium chloride salt. Okay, our table salt. And we know sodium chloride is an ionic compound. It is made up of ions. And sodium with plus 1 charge and chloride with minus 1 charge. And these two ions attract together because these have two opposite charge. Okay, these have two opposite charge, and we know opposite charge attract. And but sodium and chlorine didn't always have charges. Okay, they are electrically neutral atoms. Okay, before combined with each other, they have no charge. They are electrically neutral atoms. So in order to come together and make compound sodium chloride, these two have to gain charges. Okay, these two have to get charges. Now sodium is a metal. It gives one of its electron to chlorine. Okay, and sodium give on an electron. That's why it turns into sodium 1 plus ion, and chlorine accepts this electron, so it converts into chloride 1 minus ion. And these are two opposite charges, and opposite charges attract and produce sodium chloride. Okay, we can express this chemical this reaction like that with these numbers. Look at these numbers that I have written above the symbols of that atoms. Okay, these are called oxidation numbers. Very important terms for you. Okay, and oxidation numbers, and these oxidation numbers give us informations about what is happening with the electrons of these atoms, and the charges. What is happening with the charges? Okay. Okay, this 0 I have written here 0. With 0 charge, it indicates that sodium and chlorine starts up with electrically neutral. Okay, with electrically neutral, so pure atom are electrically neutral, and after electron transfer between them, sodium and chloride have taken on charges. Okay, sodium and chloride have taken on charges. This is chlorine and this is chloride. Okay, chloride ion. And I will discuss more about oxidation number in our next video. Now, using the oxidation and reduction concept, we can describe what is happening to sodium and chlorine. Okay, and sodium is giving up one electron, and that means it loses an electron, and that's why it is being oxidized. Okay, that's why it is being oxidized. And on the other hand, chlorine gaining the electron, and it is being reduced. That means oxidation and reduction takes place in a same chemical reaction. Okay, and now we can express this equation to write an chemical equation. Okay, and at first for oxidation. Okay, at first oxidation is sodium give up an electron and form sodium 1 plus ion. Okay, but we cannot write this. We cannot write this because in a chemical reaction we cannot use the negative sign. Okay, minus sign. In a chemical equation we cannot use the minus sign. We can only use plus sign. And so, because in chemical reaction no atomic particle or no atoms can be eliminated from the reaction vessel. Okay, and that's why we have to write sodium, then one arrow, sodium turns into sodium 1 plus ion plus 1 electron. Okay, writing this electron on the right side of the chemical equation indicates that this electron is being produced along with the sodium plus ion and no longer the part of sodium atom. Okay, and this is the oxidation part of this chemical reaction. Okay, and now reduction. Okay, I have to erase this. Now the reduction. Okay, the reduction reaction, chlorine gaining this electron and turns into chloride 1 minus ion. Okay, and these two reactions are called half reactions. Okay, these two reactions are known as half reactions. This is called half reduction reaction and this is known as half oxidation reduction. Because why this is called half reaction? Because they can individually represent the half of the whole equations. Okay, and for every redox reaction, for every oxidation reduction reaction, we can write two half reactions. Okay, two half reactions, and we can express the oxidation and reduction process like that. Here, neutral sodium with 0 charge, when transfers electron, losing an electron, turns into sodium ion with plus 1 charge. Okay, that means this process is oxidation. And for this chlorine with 0 charge turns into chloride minus 1 minus ion by gaining electron. That's why this process is known as reduction process. This is the half oxidation reaction and this is the half reduction reaction. Okay, and now we can easily understand that oxidation and reduction have to happen in parallel, have to happen at the same time in a same chemical reaction. Okay, that means oxidation and reduction reaction takes place simultaneously. I will discuss more about oxidation reduction reaction, redox reaction, and I will discuss about reducing agent, that means reductant, and oxidizing agent, that means oxidant, and about oxidation number in our next video. Okay, that's all for today. Assalamu alaikum students.